Hello. Hello, 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 hello. Good afternoon, good afternoon. Thank you all for coming. I apologize for the kerfuffle and everything outside about the food and drinks, but hopefully that'll be finished in a bit. And during our break, you can go back out and continue, stuffing your face and getting the drinks in. So, my name is Jay from Red Badger. We're hosting this event today with the help of Facebook. Two of my colleagues over there, Tiffany and Courtney, can put your hand up. Whee! They're over there. Today we've got a great lineup for you. So today we have, I need to check the names properly. So we've got Tom. Tom's our first speaker today. And then after Tom, it's Luke. And then after Luke, we have Sonia. But after Luke's, we're going to have a short break, 15-minute break, refreshments, all that good stuff. Come back in, finish off with Sonia, and go from there. Also, always hiring, Red Badger. Check our email. Yeah, jobs at red-badger.com. If you're going to tweet, Instagram, anything, #React Meetup London. And yeah, let's get this going. We are a bit late. Again, apologies for all that kerfuffle and stuff. And, we can get going. So, Tom, yeah, let's go.
All right, cool. Yeah, thanks for having me. My name's Tom, and I'm going to be speaking to you tonight to give you a brief introduction to the Context API. So I currently work at Rehab. We're a digital agency. We build digital products for technology companies. And by day, I work on Learn with Facebook, which is a learning platform where you can learn digital marketing skills, which I'm sure you've all got, so you're probably not the right target audience. But it's a large-scale WordPress and React build. Yeah, we work closely with the Facebook team here to get that out. One of the things we installed really early on was Redux when we were planning this out. And now it's got to the point where we're heavily reliant on a lot of Redux code to power kind of the key areas of the site, like logging in and tracking users and stuff like that. And it got to the point where we were even using Redux to trigger modals and open menus and stuff like that, and it started to get a bit crazy. So recently we've tried to just reduce our reliance on Redux a little bit and use the Context API to do some of that stuff. So I'm going to give you a brief introduction to what it is, how to use it, when not to use it as well. So typically at the moment we're kind of managing state in two ways. So we have simple component state over this side where stuff's really easy to manage. We're storing state within components, and then we're passing that state down via props to components lower down the component tree, and that's really straightforward and simple. And then when we outgrow that, and we'll talk about what outgrowing that actually looks like, we start to make this massive leap into like really complex lands where we're using these fully fledged state management libraries such as Redux. And stuff starts to get really complicated really quickly, especially for kind of younger developers, people who maybe don't have a lot of front-end experience or don't have a lot of programming experience even. And you start to really need to know about some functional programming paradigms, lots of things like actions, reducers, action creators, mapping state to props, and it all gets pretty crazy pretty quickly. So there's kind of this big gulf in between, or has been for a while. And the pattern at the moment has been to try and outgrow your simple state by lifting your state up as far as possible and then passing it down. And then when you've outgrown that and stuff starts to get unwieldy, where you've got large lists of props and lots of stuff being passed up and down the tree, that you make that leap into a large component, large state management library. So when we talk about lifting state, we're talking about we share different pieces of state across the component trees. This is just a toy tree. And you'll see that we're relying on current user in two different components. So we have account and we have user. They're different parts of the application. And the problem with lifting state is that we typically need to lift it up to the highest common parent component. And then we need to pass it back down again. So when you've got 7 components, that's really, really straightforward and quite easy to manage. When you've got 100 components and the component tree is very wide and very deep, and that starts to become quite unwieldy. You also introduce another problem, which is called the prop drilling problem, where we have two components here, the account and the user component, that need to know about the current user, and yet we've ended up by lifting state and making almost every component in this tree aware of current user, and it doesn't need to know about that at all. Yeah. So there's that middle way. There's this middle area between this simple pattern of prop drilling and the problems that creates, and then the full-on Redux state management library and the complexity that comes with that. And about a year ago, React made public the context API, which was always kind of there, but it powered some of the internals of React and wasn't actually kind of consumer-friendly at the time. So they packaged it up, they've created an API for it, and now it's available. And the way they describe it is that context provides a way to pass data through the component tree without having to pass props down manually at every level. So it solves that problem of prop drilling, where you're kind of passing down state through components that don't necessarily need to know about that state. That creates tight coupling as well. So you have lots of components that are expecting props to come in and pass them down, and they just don't need to know about those props at all. So it's very difficult to kind of get that reuse. Composition will get you some way to being able to share that state, but context is a really nice kind of like halfway house between pure passing around state as props and Redux. So there's three key things you need to know about context. The first is where it all begins, which is create context. It's a function provided by the React library. This returns two things. So we have a provider, which the two things here are fairly self-explanatory, the provider and the consumer. The provider provides some state to a subtree of your tree. That could actually be the entire tree. And the consumer is that little kind of pocket, that little window that you can grab into the global state store. And I use the word store just because that's kind of the terminology that Redux uses. And you're able to reach into that global store and pull out what you need in the consumer. The provider accepts one prop, which is called value. And then that value prop is typically going to be an object, again, similar to the store that you get with Redux. And that's going to store lots of different props, but you can also have methods and primitives in there as well. You can actually, it doesn't have to be an object, but typically it will be unless you're storing just one thing in state. So you create context, and you get your provider and your consumer back. So you need to think of context as kind of the invisible wiring between all your components. It allows you to share some state between them, but only using consumers where you need to actually bring in that state. So our toy tree here now starts to look like this. So we have a provider at the top wrapping the entire tree. You'll notice we have current user, which sits in some state within a component that we're going to have a look at in a minute. And then we've created two consumers that create these windows into that state store as well. And then here we're able to reach in and grab the current user state and just use it in those components. No other components in this tree need to know about the current user prop or state. So create context is where it all begins. It's a function provided by React, and it accepts some optional parameters. Optional properties. You don't need to put in these defaults here. You can use it without it. There's two good reasons to do it. First is that very quickly I can look at a create context function and get a feel for the shape of the state that's going to be passed in. So it's good for sort of developer understanding of what's going on. And secondly, a consumer doesn't need to be used within a provider. You can use a consumer outside of a provider, in which case it will fall back to the default properties here. And a consumer won't error if you use it outside of the provider. Your values will just be undefined if you don't pass in some default properties. So the provider wraps everything that you want to give access to context. Typically, you might put that right at the top of your component tree and just wrap the entire application in it. That's fine. You might choose, if you've got multiple providers, which again, you can have multiple contexts within an application, you might want to split things out and try and limit the scope of the provider to the subtree that actually needs to consume that state. And then the consumer just opens up that window into the store that you can then grab out the state pieces that you need to use. Now, the important thing about the consumer is that it expects a function. It expects a function as a child within the component. So something like this would not work. This would error. You need to use this pattern. So what we're doing is we're passing it as a function as a child. We're grabbing out the username part of the store that we want to use, and we're destructuring that, and then we're using it in a div in this case. But this is the pattern that we need to use. We'll see in a bit that actually there's been a bit of a advancement on this, especially using hooks, that we can actually simplify this quite a lot. But for the moment, let's just understand where this has come from. So I'm going to talk you through very quickly how to make a context-driven modal. And I'm going to provide some links afterwards. You can get some code as well. So the first thing we're going to do is set up a context file. And then we're going to create a class called myProvider, which acts as a wrapper component around the myContextProvider. So first things first. We're going to define a variable, and then we're going to call create context. We're going to pass in some default arguments there, some default properties. So we've got a username string, it is open boolean, and then a toggle modal, which is just a method that's going to be used to show and hide the modal. So that's pretty straightforward. And then we start to build this myProvider class, which, like I was saying, acts as a wrapper around the provider that's going to be returned to us by calling create context. So this is fairly standard. We define some state here because we need a vessel to carry around this state. Context itself doesn't actually provide a store like Redux does. It needs somewhere to take that state. Think of context as simply the wiring that's allowing you to pass around state. It doesn't give you that state for free like Redux does. And then we've got the toggle modal method, which just sets the state of is open to whatever it currently isn't. And at the bottom, we're rendering out the myContext.provider, which is the provider that's being returned by the create context function at the very top. And then we're passing in that single value of this .state, so the state of that class. And then we're just passing in the children as well, so this acts as a wrapper around it. So it's syntactically going to be a little bit cleaner, and it also means that we're storing the actual state object itself within this class. And then it's pretty straightforward from there on in. We really need to just import the provider and the context. And then we want to wrap the provider around the part of the tree that we want to expose the context to. In this case, I've wrapped around the whole thing. Like I was saying, it doesn't have to be that. You can partition it to different parts of your application if you prefer. And then we've opened that consumer, so we've opened that little window into the state that we defined within myProvider, and we can reach in at any point and get this. And then we're using that function as a child pattern below that. Destructuring is open, which is our boolean, and then we're conditionally rendering the modal. Now this shows an example where myProvider and the consumer are actually in the same file, but it doesn't necessarily need to be the case. So long as the part of your tree that's wrapped in the provider, you can insert a consumer. So for example, for argument's sake, this is a header. This is using a completely different part of the application. All we need to do is import context, use the consumer, function as a child, grab in what we want for this particular component, which is the username and the toggle modal method. And then we're using the username within the return statement, but then we're also able to, it's very simple just to pass that click function back again into the state store. That'll trigger the method. So we're not only able to read stuff using context, consumers are actually able to put stuff back into state and make changes to state via this very easily. Now, hooks make it nice and easy, actually, to tidy up some of that function as a child pattern, which is a little bit, when you're using just one consumer in a component, it's not too bad, but you're actually able to nest consumers as well. When you've got functions returning consumers that return, and you need a function to return another consumer and so on, that nesting gets a little bit cumbersome. So with the advent of hooks, we're actually able now to simplify that quite a lot. So you can see here we're actually just using the use context hook. We pass in the entire context object, context class, sorry, and then we're destructuring what we need, and then we have direct access to it. So we don't need to use that function as a child pattern anymore. So hooks have solved that problem for us. So if you're able to use hooks now, this is probably a cleaner way of being able to access your consumers. And then testing is really simple. There's no magic with this. These are just components. So in this example here, we're just mocking the value prop being passed to the provider and checking that the header is actually rendering out what we expect it to at that time. So I'm mocking the username Dave, and then I'm expecting that this component renders hi Dave. So this example uses React testing library, but afterwards I'm going to provide some code samples for you. There'll be one with just context on its own, one with context using hooks, and then a couple of test examples, one using React testing library and also enzyme as well, very similar really. But yeah, very straightforward to test as well. So there's those three parts. We've got the create context function, we've got a provider that provides state to a subtree, could be the whole tree, and those consumers which are only used where you actually need to access state. Much cleaner than passing props down and lifting state up and passing props down again. And also much simpler than Redux. So what now for Redux? And well, there's been a lot of noise about context and especially hooks together, kind of replicating a lot of the functionality of Redux. My view is that Redux is a great tool and you get a lot of stuff for free that you have to do yourself using context. And you can get a certain amount of the way trying to re-engineer what Redux gives you, but there's still a certain use case for using Redux, including the great dev tools as well, the time traveling and stuff like that. That's really, really useful if you've got kind of complex state interactions happening. You don't get any of that with context. So you should use context sparingly and typically with maybe things like conditional rendering of show hiding components and stuff like that. That's where context is really well suited to. So you might want to use Redux when you need the great dev tools that come with it. If you're using third-party middleware, that's a good use case for using Redux. The performance optimized for you. If you're not careful with context, you can end up re-rendering a lot of components you don't need to. You need to be careful that the value prop isn't past things that the reference in that prop is going to change, because even though it might look like the value is the same, if the reference has changed, the provider will re-render all the consumers. So you just need to be careful of that pattern. Redux does a lot of that kind of performance optimization for you. And if you're using a lot of kind of advanced actions, if you're using asynchronous actions, if you like using thunks and things like that, then that's probably more in the Redux realm. You can stay there. But you should consider context when you've got fairly simple state changes. And typically, when you're writing more Redux code than the actual feature you're trying to implement, then you know that that's going to be a problem. Especially for things where, like I say, conditional rendering as simple state changes, this context would be a great opportunity to use this. And also, if you don't have sort of heavy debugging requirements as well, like I say, you don't get that time traveling. You can't drill down into it. It's just a lot simpler. There's not so much overhead with context. So that was a brief introduction to Context API. Hopefully, you can see opportunities there to reduce your reliance on Redux for simpler sort of state patterns. I'm going to put some code samples on my website so you can see those. You can see it in action. If you're interested in reading more about context, particularly context plus hooks as well, there's 3 resources here. Dave Sedia's course on Egghead is really good. James Nelson wrote a really good article on the performance of the Context API. And annoyingly, Kent Dodds basically wrote this presentation yesterday on his website as well. So if you didn't understand a word I said, just go to Kent Dodds. He'll explain it much better than I did. Thanks very much.
Okay, couple questions.
Yeah, sure.
Anybody got any questions for Tom? Yeah? Let's see if I can get around here.
Just a quick one. Use Redux versus importing Redux as a third-party library. Have you looked much at the use Redux Hook?
No, I haven't got much experience with Hook beyond context at the moment. So yeah, really just using. What was it? Sorry.
Any other questions? No? Okay, cool.
Thanks a lot.
All right. Hello, everyone. My name's Luke Jackson. I'm from a company called Formidable. We do cool React stuff for people, so if you need anything cool doing, let us know. Today I'm here to tell you, don't build that app. I'm really here to promote simplicity. I'm not that clever, disclaimer. And recently, things have been confusing me a lot. The web development seems to have got very complicated. And so I've been on a mission or a journey to uncomplicate those things. So before I get started, oh, by the way, we have to have this bar at the top because Google Slides suck. So this, I'm going to tell you a story, and this story started back here. I'd just moved to Boston, Massachusetts, to work for CS50, which is Harvard's Introduction to Computer Science course. And as you can see, I'm quite a minimalist. This is everything I took to America, bar some bag of clothes. And that was my room, which I paid $800 a month for, which was upsetting at the time. And this is some of the work we did there, so it's sort of my minimalism really is reflected in that. I'm a designer developer, so bear with me. Quite early on in my role there, I was asked to make a video player for the course, or like an interactive experience for students. I hadn't worked with React much at this point. My previous company was using Backbone and Marionette or something like that, and CS50 had not adopted React either, and they were using jQuery still. I couldn't bring myself to use jQuery at the time, because I knew, even though I wasn't using React, I knew it was frowned upon. So I had the brilliant idea of making it vanilla JavaScript. And you can go check this out on the repo. It is still all vanilla JavaScript. I made a really weird React-like framework in about 20 lines. But we ended up with some nice things, search captions and split screen mode and VR mode. And I learned a lot on the way. One thing that really stood out for me at the time was browser support for language features was pretty minimal. This was about 3 years ago, so ES6 was up and coming, but nothing was quite there yet. All the things that make JavaScript bearable nowadays just were flaky as hell, so you need to polyfill everything. And also, splitting your code up into modules. Like, as much as you always dream about having your code base in one single file, like, it can't be that hard, right? We'll just inline everything. Then we don't need modules. You do need modules. And so being engineers, we solved these problems, right, with a plethora of tools. These tools made it very easy to add hundreds of dependencies to your project. I think we probably started with Browserify and Gulp, and then slowly moved into Webpack, and more recently Parcel and Rollup. And due to the diversity of project requirements that these things like accommodate, they need a lot of configuring. So now the web development was easy, right? We get modules, but you just need to install half the internet and know how to configure every single tool. I do actually remember David Malin, the guy here in this talk, head of CS50. He was trying to install this site in a Docker container, and with limited CPU and network resources, and just turned around and said to me, "What the hell is this wall of CLI?" when he was doing npm install. And I was like, I'm sorry. Even though it's a vanilla app, it's crazy. And that really made it clear to me that something was a little bit off, And this is me when I made a lot of these projects eventually, and every time I came back to them, there was some peer dependency of a dev dependency that had a dependency on something else that was just broken or incompatible nowadays. And I was just like, please, I just want to write HTML and CSS. That's what I'm good at. That's what I enjoy doing. I don't want to have to do this battle every single time. there were no official standards, and overnight things just changed, don't they? And maintaining a reliable build chain did genuinely become a full-time job, and probably still is now. You do get like Webpack engineers, and that's just crazy. Then this happened. Thank you, Facebook. They created Create React app, which promised to deliver on simple. It was zero configuration. Everything was behind one dependency. You update that dependency, and they'll figure out the rest for you. Great. And what's more, it worked like reliably across platforms. Like you don't have to worry about Windows or Linux or Microsoft anymore, or Mac, sorry. And I was teaching Code Club at my old employer, Pusher, for a while, and I would like quite happily advocate Create React app because it gave this sort of trivial development cycle, like it made this quite apparent. You write some code, you hit save, check in your browser, wow, look, it's there, right there. Everything brand new, everything works, cross-browser, no worries. It was certainly refreshing, at least for a lot of like developer designers like me. I can see how it was very much like appealing. It was all very appealing. But there was one problem. As you already know, I'm a minimalist. I have a minimalist spec MacBook. It might be a new one, but it's the lowest end one you can get by choice. No touch bar. And these days, that means 128 gigabyte hard drive. And my hard drive was saying it was very full. I have no videos, no games, no pictures, nothing on my laptop. My laptop is purely for code. And I couldn't really believe it. I was like, well, that's a lot of code. So I dug around a little bit and sort of sorted all the files by size. And sort of these Create React apps were all at the top. And you can see here, it says 112, but in reality, it's 185 megabytes on disk. 28,005 items. The 5 items were probably mine. The 28,000 were not. And I did not have a clue as to how any of those worked, particularly. And this was quite shocking to me. Now, I'm not a mathematician or anything, but I did do some sums, and it turns out you can probably get around 5.4 Create React apps per gigabyte, which doesn't bode well considering how many prototypes and React apps that I have made on my laptop. And I could just see other industries laughing at us right now, or other developers, other languages, like, you don't need this kind of stuff. Einstein managed to pretty much condense how the workings of the universe into like 5 bytes, and we were needing 185 million bytes to describe our React apps every single time. And this was too much. So I really started to think about this mess we got ourselves into, and I realized that I'd resigned a lot of my knowledge, or a lot of my, knowledge to node modules. A black hole, which I just didn't know what was going on in there. I knew tools through repetition, like not understanding. I was just doing them every single day, and eventually you get to know them. But then as soon as they change, your knowledge is just discarded. Pretty much everything you learned, forget that. Just learn the next new thing. I'm back to square one. So I was having a quick look. I was like, what's the solution to this problem? And I went to the Create React app repo, and the answer was there pretty much in black and white. It says Create React app is a great fit for these 3 things, learning in a feature-rich environment, starting new applications, creating examples. But here are a few common cases that you might not want to use Create React app. And the first bullet point is if you want to try React without hundreds of transitive dependencies, which is exactly what I wanted to do. I wasn't really using React still at this point, probably because of this reason. But I was aware of what came with it. And surely there must be some kind of middle ground. So I had a few weeks off work, or months off work as well, in between jobs, and I decided, well, I want to learn exactly how all these tools work. So I wanted to create a Create React app experience, like dev-like environment, from scratch, but without any dependencies. I wanted to see how far I could get, not knowing if I was actually going to ever make it or not, but I wanted to see. So I set off on this journey where anyone would, I guess, in an index.html file. This is still the pillar of web development. It holds everything you need, scripts and styles, and a bit of HTML markup. But this isn't quite what we're used to seeing, because those have no framework, and everybody knows you can't build the web without a framework. So, taken from the React documentation, whack some script tags up there, and have yourself some React, right? This is pretty much the simplest React app you can do. This is what it says on the website. You can double-click on this index.html file, and there it goes. It whacks up. But I can already hear the hissing and the whispering and everything. So how's that? Everyone says you can't use create element like this because it's way too verbose. So that's easy solved. We just take inspiration from jQuery and make our own. And I mean, I know what you're thinking. Designers and their tiny little brains, how will they possibly comprehend 3 positional arguments? But you know, it can work. Trust me, I am a developer designer. So bear with me on that one, the whole JSX thing. I will come to that. But first, our project grew. Oh look, a wild counter component has appeared, and somehow we need to get that into our app. Like, this is the first abstraction, right? The first component that we might see in a hypothetical app. With Create React App, you would do import some statement, and Webpack would handle that all under the hood for you and pull everything in, inline it, code split it, chunk it, do whatever it thought was necessary. So I started asking myself, well, how does Webpack work? And could I re-implement Webpack myself? Maybe that would be fun. So I started watching a talk from Sean Larkin, and he was talking about compilers and compilation modules, recursive run loaders and resolvers, and I was thinking, well, this can't be, no, I'm not, I'm not going to do this. I'm not going down this road. This seems crazy. There must be something easier than this. Like, we all survived before Webpack, right? So instead, I'm going to pull on my favorite learning resource, Google. And I typed in exactly what I want, and there we go, top answer. It says Node.js. I was like, oh, well, I'll cross my fingers and I'm going to click on it anyway. And it said here, old versions of JavaScript had no import. But since 2015, ES6, JavaScript has had ES6 modules, which is also supported by most modern browsers. And this blew my mind. I was like, hang on, this looks exactly like the Webpack that we used to use. The Webpack syntax, this is exactly what I'm used to anyway. It's got to be too good to be true. So let's see how that works in our app. And I tried it. I literally typed these words with a counter example. Export const counter at the bottom, little simple, very simple element using a nice jQuery syntax. And then the top one as well, we can just see we pull in a counter and create that element as well. And it worked. It just worked, just like that. We didn't have to install anything, download anything. This is the sort of spec, or this is what we're dealing with here. This is called a static import. It's good for loading initial dependencies and can quite easily benefit from static analysis. Like, you could, if you had a big project of this, you could just run it over grep for imports and do some crazy analysis on it. It's almost too easy, I was thinking. And you might be thinking this too, like, well, yeah, this is probably like 2020 kind of stuff. Majority of browsers aren't going to support this. But if you did think that, you would be wrong. To use import-export, you need to nest your code inside of a script with type module. That is it. That's the only sort of prerequisite. And you can think this a bit like useStrict. Like, once you're in this environment, everything's sort of safe. And you can use type module with pretty much all the evergreen browsers, even some of the crazier ones. It's fast becoming very standard. And what's more is that static imports or script type module is probably one of the last sort of features to land in ES6 and be fully supported. So you can guarantee that if you've committed to this script type module, then you can go ahead and use all the other crazy syntax that we love now. Like const, let, async, await, object spread operators, nested. You can use all of this with like full confidence that if we've supported script tag, we're going to support this, which means Babel has become pretty redundant in this toolchain already. This is the future, I guess. But there is one exception to this rule, and it's quite a useful one. I don't know if you've seen it before, but this is a new keyword in JavaScript as well. It's called dynamic import. And this is useful to doing things like lazy loading. You can conditionally say, hey, if X is true, then import this. Otherwise, import something else, perhaps. And it's a promise, and it returns you the module. And then you can go ahead and use that module inside of there. I'm not sure if you can await it yet. That would be nice and clean. You probably can. It's just a promise. And you can see this actually promoted in probably best in the React.js docs themselves. It says bundling is great, but as your app grows, your bundle will too. Get ahead of this problem by splitting your bundle, and the best way to introduce code splitting in your app is through dynamic import syntax. So you can forget Webpack already, because Dan said it. If you want to know more about that, go ahead and read in the docs. And this is kind of, you can see the React team must have been thinking about it on some levels because they created these two components, suspense and lazy, which lets you use a component asynchronously, I guess, and it will await for that to resolve and then render it, which is pretty cool. But Firefox screwed us over. So now your product manager's going, yeah, I know it's great, but you can't use it in Firefox. So you can't use it at all. Fair comment, kind of. So I reached out to somebody, or somebody actually saw this in a project of mine, and he's called Luke Edwards, and in about a week, he'd whipped up a polyfill for both static and dynamic import and export, which makes it work in any browser, including, I think, down to IE9, which is crazy. To think we didn't do this, we didn't even think about doing this when we had IE9, but it's always sort of been possible. It does do a bit of magic in there, but hopefully we won't need this for much longer. So remember these two things we said at the beginning? We pretty much ticked them off, and we've done it for free. We can use ES modules for splitting up our code as modules, and the support for language features is pretty much nixed by the fact we're inside script tags, so we know everything's available, and we have a polyfill for sort of the last one. Perhaps babbling and also webpacking could be done. There is a case for doing it at deploy time, or deploy time once rather than in development. But for development, if you're using Chrome or any evergreen browser, I really think we can strike these two things off. But I hear you all again. Yeah, what about the poor designers and their tiny little brains, and they want to really write HTML, right? And surely HTML is not part of the ES6 syntax or like spec. And no, it's not. It's a proprietary language developed by Facebook and maintained by them. Usually Babel would handle this under the cover. This is probably what you've mostly been using Babel for. It's like you've been kidded into using Babel to transpile stuff, when really it's probably just your JSX. I don't know if you've ever tried to just transpile JSX with Babel, but it's really hard. I have. So before implementing a JSX parser myself, which sounded like way too much hard work, I had a quick Google, and it turns out somebody else has done it already. This library is called HTM. It's developed by Jason Miller, also known as Develop-It from Google. Really cool guy, makes a lot of really cool packages, this being one of them. It's pretty popular. And straight from the README, he wanted to use a virtual DOM, but wanted to eschew build tooling and use ES modules directly. Rock on, Jason. It boasts some pretty cool features. Less than 600 bytes. Optional quotes, which is cool. Self-closing components. You can literally, this doesn't have an example of it weirdly, but you can put double slash at the end of a component, and it'll just close itself, which is really cool. You can write comments, which is nice. And you don't have to write class name anymore. You can just write class like normal people do. It even has like really crazy features, like you can have a fragment as the root of your app, which I don't think is even possible without this. Maybe I'm wrong. Syntax highlighting works pretty much via the lit HTML extension, which was by Google as well, I think. So how do I add this to my app? Well, it says there, right there, via npm, just npm I, htm. Don't really want to do that. We've managed to get away without any of that for now. So what's the next one? Hot linking from unpackage, no build tool needed. Ding, that sounds good. And then, so what we got? Import HTML from https unpackage.com HTML module. Sorry, what? You can import files directly from the internet. Did anyone know this? Put hands up, anybody knew this? No, mental, right? Crazy. You can import files from your JavaScript from anywhere on the internet. This is going to become a thing, and it's probably going to be supported by Unpackage. Has anyone heard of Unpackage before? One or two, maybe. Well, these guys are really ahead of the curve. I say these guys, it's actually one guy. This is a mirror of NPM, but it's better because it's not NPM, and it's not run by assholes. I hope that's not libelous, but you can use it to quickly load any file from any package using a URL of this sort of schema. It's pretty crazy. Just to show you, it's not like a pet project of somebody's that might disappear tomorrow. Well, it is a pet project of somebody's. It's a pet project of Michael Jackson. But he is a prolific, well-known developer in the React community, and it is backed by Cloudflare. In the last month, look, Unpackage received 16.4 billion requests. That's 215 terabytes of data, 1.4 billion unique visitors. And to his credit, 99% of all of these things were served from a cache, which is incredible. So there's considerable effort gone into this. It's proven scalable, and it's probably only going to get bigger. So what does this look like when we add HTML to our, let's get back to the JSX, to our app? Well, you can see we're just going to render, instead of our create element calls, we're going to just render some HTML, exactly like you would expect. You've got some weird things here, like this isn't quite as clean, we're going to have to interpolate here, but no big deal. And we do that in both our components and our app. So this got me thinking, well, what's next? We've got our app, we've got JSX, we're not using Babel. We do need a server, I think. We need localhost, right? Just like Create React App does. And we don't want to compromise on like all the niceties, so we're going to want live reload too. Now, I looked around for a lightweight static server with live reload, like Create React App provides for you, but I really like Zeitserve, but they don't have live reload built in. It's unfortunate. It turns out live reload, like historically, has been done by WebSockets. WebSockets are pretty heavy. I didn't want to do any of that. Like I said, I wanted to build my own stack and understand my own stack. I didn't want to employ anything. So I created Server, which is a single file zero dependency server with live reload and history API built in, history fallback built in, which is perfect for single page apps. It uses Node, file system watch, in combination with a keep open connection and the event source API. It's a single file. It's probably like 100 lines. I'd encourage you to go check it out because I learned a lot making it. Maybe it'll be useful for you. So back to our app. Everything is working well, but I'm looking for further ways to improve this. Like I'm running my app now. It's going pretty good actually. This reliance on global, like on window, is really annoying me. And this duplication here is annoying me. So let's see what we can do about it. Let's first address the first one. Now I was thinking, if we can import HTML as a module like this, maybe we can drop our reliance on window by just importing React straight into the browser, like into that file. And I was praying this was the solution. But unfortunately, you can't, which is annoying. Hint, hint, if Dan's listening. But he made the issue back in 2017. He said, we want to make an ES build of React. But they said it's not an easy feat because they can't decide on what top-level ES exports would look like for each package. Well, I thought, challenge accepted. So I rolled up my sleeves and got my hands dirty a little bit. I ended up creating a package named quite simply ES React. And it allows you to import React exactly like you can other frameworks like Vue or HyperApp, etc., other VDOM-based frameworks. Turns out deciding what top-level exports would look like wasn't so tough. I literally just copied the UMD exports, and that will have everything bound to it, as you would expect. Everything that's available on React and React DOM when you import it as a script tag is available through these two variables. Simple. So this is from the repo in that of ES React. And I would say that this is the most simple React app like you could ever make that includes JSX and all the other things that come with 16.8.3. You can literally copy and paste this exact code into an index.html, double-click it, open it, and it will render a React app, which sort of really blew my mind. Started to think this is the future. No more dependency on window, much better. But we still have this sort of duplication here. Oh, by the way, we can drop our script tags. That's it. They're gone now. Which really makes this nice and generic, which is kind of cool. This index.html is not doing anything special. But back to our script, we have this duplication, still annoying me. I'm a slow typer. I didn't really want to do this every single time. So I asked dev Twitter, and I asked developer, if you're using this pattern like we are using here, what would you do? Would you bind it to window.html? I was kind of hoping he wouldn't say that, but he did say that. But luckily, Joachim, I think that's his name, he's a contributor to HTM as well, and he said, wouldn't a small module do? Why don't you make this HTM bind React create element? Just make that once, and then import that whenever you need it as HTML. I said, oh, well, that sounds a great idea. I don't know why I didn't think about this. And then I slept on it, and then I took it a little bit further than this, and I created my own little React module. I bound it with HTM. Like we can see, we're doing this binding, and we're doing it once. I also employed a CSS parser that I was doing because I wanted to have modular styles as well. This is a CSS in JS solution, but really lightweight. I've spread React and then just plucked out React DOM.render because that's pretty much all I use from React DOM and bundled it inside of a thing called React. So now we export three things: React itself, HTML, which does the JSX parsing, and CSS, which will do a similar job for CSS parsing. Disclaimer, this is published, but it's completely undocumented. Well, the documentation's there. That's it. If you want to know about each part, you go and look in the individual packages. That's it, two files as well, just one simple package JSON and index. This is all it took to create my own version of React. So now our app looks like this. This is super clean, super simple. I like it. No WebKit, no Babel, no worries. So I've bundled all my learnings that I've said today into a quick start template called Create ES React App. As well as demonstrating some of the techniques we've talked to today, I've gone and explored simple routing, code splitting on routes, and some styling. I encourage you to go check it out again, see what it's like. And just for comparison, quick comparison, compared to the 5.4 that you get with Create React App, you'll get 4,784 Create ES React apps per gigabyte, which is much more reasonable, in my opinion. And here's a production app built from that exact template. I made it recently to test the sort of build stepless architecture, see if it'll actually work on a real thing. It's a modern alternative to JS Perf. You can race scripts against each other. and quickly prove to your colleagues just how much quicker that while loop is than the for loop or the map. It's on Perflink, but it's also on my GitHub. Feel free to check out the source code. If you're interested in seeing how it got quite a bit of attention, weirdly, and Sean Larkin did see it himself and created this issue to try prove the value of Webpack. He has done some experiment and a quick rundown. It's quite interesting reading. I've continued to comment along with a guy called Fred Schott, who's the creator of Pika Package, which is like a weird middle ground. And I think we're going to try use this as a testing ground for comparing fully bundled, fully ES modules, and then this middle Pika Package in the middle. It'll probably be quite fun. Please chime in if you have any thoughts. So that pretty much brings us to the end of the adventure. And in conclusion, the landscape is changing pretty quick. I mean, that's not uncommon, right? In JavaScript land, things change all the time. But I really do think this is changing for the better now. And with fundamental shift in paradigm, people are always going to find edge cases, right? But I do believe the ES module architecture is so simple that it will be sufficient in most use cases. Hold me to that, please. In the interest of fairness, here's some things that might trip you up and some counter comments. This comes from a blog post that I wrote recently, which the link will be at the end. If you want to find out more about sort of this and this exploration, then please go check that out. Please and thank you. I was Luke Jackson. Thank you.
Okay, do we have any questions for Luke at all? No?
That's good.
Oh, wow. No, we got one.
Go on then.
Let's get it.
I like to program on the train, on the tube. What would you need to change? I guess you couldn't do the network calls to pull down the modules, so what would you
No. So, yeah, no, you're completely right. That is a pitfall of this and could be remedied by something like Pika Package, which will scan all your files for imports of certain packages, quickly go fetch like single files from unpackage, wrap them up in ES modules for you, like quite magically as well, which is nice, but it literally just puts import and export statements at the top and the bottom. And then it just puts them in a like web components folder, it's called. You'll find it's like a 10th or 100th the size of the node module comparison when you pull it down. But it will require you, before you set off on your train, to run Pika Package, and it should work. Disclaimer, I haven't tried it yet, but I think that is theoretically how it works. The other alternative is literally just to copy and paste the source code from unpackage and have it as a local dependency. It seems crazy, but it's not. It's not the most crazy thing that we've done as web developers.
Any more questions? No? Okay. Ladies and gentlefolk, I shall now leave you in the capable hands of Sonia. Enjoy.
Hi, everyone, and keep calm and secure your CI/CD pipeline. So I'm Sonia. As you can see, I wear dark hoodies, so I'm a legit security engineer. So I wanted to do a little bit of an introduction on cybersecurity and why is it important. So cybersecurity is the techniques of protecting computer networks, programs, and data from unauthorized access or attacks that are aimed for exploitation. And what we see these days, and companies are doing investments in security, move from nice to have to must have. If you remember, in October 2016, there were a series of DDoS attacks. They were launched against DNS servers, which caused major disruption to several web services like GitHub, Spotify, Twitter, and you could see the unicorn from GitHub. So how do they do this? Are you familiar with Shodan? Shodan is basically like the Google of IoT. So for example, if you type webcam, you would have all of the webcam connected to the internet. So basically, the attacker would actually zombify some of those devices and launch an attack against the server. And then that's where you could see the pink unicorn from GitHub, for example. This is another example of cybersecurity attack. This is a ransomware from WannaCry in 2017. So basically, you could have, through a phishing email, you click on the email, give your credentials, download the malware, and then encrypt your data. You have to pay bitcoins to have your data decrypted. Yeah, and actually WannaCry reached out to 130 countries. That's another example. You might probably actually receive this in your spam. It's called the porn scam email. So basically, what happened, the attacker would put the blurred part would be the password, and tell you that they actually monitor, recorded what you've been doing in front of camera, and ask you to send some Bitcoin. What I would recommend is actually to take this Bitcoin address and go to any Bitcoin wallet, and you would actually check those. That's a scam. Just like nobody actually gave money to them. Also, how did those attacker actually got your password? You can go to Have I Been Pwned, which was created by Troy Hunt, an Australian researcher, security researcher, and just put your email address and see which accounts have been breached. Are you familiar with Dominic Tarr? Anyone here? So Dominic Tarr is a famous maintainer, especially from the event stream package. So you could see it's quite a popular package. So what happened last year, there was actually a malicious flat map stream package that was injected through the event stream, and it was pushed by right-line control. It has been downloaded 8 million times, so the application all over the world were actually running malicious code in production. And this was the target. It was actually a Bitcoin wallet, just to siphon Bitcoin wallets for this. So what happened? Basically, when you have an open source project, you would actually raise issues, and the attacker went through all of those issues and read this line: if you publish a flat map module and then make a PR to include it, I will merge it. And this is basically what he has done. He has pushed a flat map module within the event stream. So since then, the repo has been archived. You can see at the top, you can't actually push anything. They've removed all the maintainers. That's the attacker, right-line control, but because Google is Wonderland, you can actually still see the profile, even if it's pulled down. And usually when you have to upgrade your packages, you have to put a specific commit, and this is what they wanted to, the kind of commit you can find. So what about web app security? So web app security is a branch of InfoSec that deals specifically with security of websites, web app, and web services. But I want to focus specifically on secure software development lifecycle, which is a framework that defines the process used by companies to build an application from start to end. So you might be familiar with this from the planning, then requirements, designing with designers. The developers would actually develop the software. The QL would be testing it, developed, and then deployed, and then operation and maintenance. So then security actually could be implemented through all of those stages, through pen testing, code review, architecture analysis. They're all integral part of the development effort. So why are we doing this? Actually, it's good to have all the stakeholders aware of a security consideration, and also because early detection of flow will actually reduce the cost. You don't have to fix it later on. So how do I get started? Are you familiar with OWASP here? So if you raise your hand, cool. So OWASP stands for Open Web App Security Projects. It's basically a community dedicated to enable developers to code secure app. So this is the website. So basically, those are all the application tools, standards, complete books. Everything is free on their website. And we're going to introduce 3 of them. You're probably more familiar with the OWASP Top 10. So the OWASP Pro Control, Proactive Controls is a list of security techniques that should be included in every software development project. This is the Top 10 Proactive Control. So the first one is to define security requirements. Regardless if it's new features or addition, you should actually have some security requirements. I will go through the OWASP ASVS, but just to show you, because you might be familiar with user stories, but you can also implement abuse cases. This is an example for the OWASP Top 10 broken authentication. You have example of abuse case. So for instance, as an attacker, I have access to hundreds of millions of valid username and password combination for credential stuffing. You don't want this, so you're going to write a story around it. Also, leverage security frameworks in library, which basically don't reinvent the wheel if you have, there's already frameworks that already exist. So for example, React, which is considered maintained and secure. So if you're using a framework, you can just go to the GitHub repo and see how many stars, how many maintainers, contributors, how many commits, and then you see that the framework of the library is usually maintained. You can also go to the registry, the NPM registry, and see how many weekly downloads you have through any frameworks or libraries you want to use. So how to implement best practice? Usually use libraries and frameworks, like as I said, from trusted sources that are actively maintained and widely used by many applications. Also, that one is tricky. Create and maintain an inventory catalog of all the third-party libraries and components that you're using, and proactively keep libraries and components up to date. I'm going to show you some tools how to do that one. So the OWASP Top 10 might be actually familiar with that one. So they usually issue those every 3-4 years. The latest is from 2017. As you can see, it didn't really change for the 4 years, during 4 years. So what are application security risks? If we're taking back the example from Dominic Tarr, so the threat agent would be the right-line control, and through social engineering actually managed to implement this flat map module through the event stream, and then the impact was on the Bitcoin wallet. And lastly, the ASVS is basically just a list of requirements on all of those, like authentication, access control, API, web services. This is just an example of the first one, especially the first line. Verify the use of SSDLC that addresses security in all stages of development. So this was the theory. Now I'm going to show you how to secure your open source project with Pride in London. So first of all, if you don't know, GitHub has a lot of documentation because they're organizing Open Source Friday, and also you have a Hacktoberfest. Basically, you have to do 3 PRs, and you can get a free T-shirt. That's why they said that. So Pride in London is open source project, and we're doing the new website before Pride. But most importantly, this is the stack that we're using. So we're using Gatsby for the React, the JS framework. We're using Contentful to fetch the data source. We're hosting on Netlify. We're using CircleCI for the continuous integration. We're using all this set of tools that I'm going to go through for accessibility, code coverage, code review, and security. Everything is linked to and fully integrated through Slack, GitHub, and emails, and we're monitoring through Rollbar. So all of those actually tools are available on the GitHub Marketplace. So the GitHub Marketplace has been in place since 2 years. It has more than 50 tools, and they keep updating those tools. This is just an example for code quality. You can see there is a lot of tools on the GitHub Marketplace. And for open source, they're all free. They all have a free plan. This is just to show you that we've actually been trying a lot of tools. And if you want to find them within your repo, you have the third-party access and install GitHub apps. This is usually where you will find the tools that you've installed. And if you're wondering which right they have permissions, usually they have read-only access. And I would recommend actually to cherry-pick your repo, like you would have only select specific repo instead of installing to all of your repos. So for continuous integration, we're using CircleCI just to have view on every branches on success of failed builds. Yeah, so basically, it's spinning up an environment with a Node Docker image, and then goes through several tasks. Here we're using Yarn. This is just an example of the YAML config file using Yarn. If you're using NPM, you can go to CircleCI. They have really complete documentation on that. And this is also where we're hosting our environment variables. For accessibility, we're using access lints. This is a good example of false positive, because usually those tools might actually raise a lot of false positive. As you can see, this is just a test file, but it's triggering an alt attribute missing, which is fine because there's actually an image tag, but it's not relevant in this case. We're using CodeCov for code coverage. So usually it goes through every branches and every PR. It will scan it and give you the delta if it's increasing or decreasing regarding the code you're pushing. And also, it will fully be integrated through your PR within GitHub. For the code quality, we're using Codacy. We're actually using 33 tools for code quality. So as you can see, at first, actually, I've turned on all the rules, because it works with code patterns. So I've set up all the rules, so you would see like an insane number at the beginning, like 10,000 issues. And then I start tuning in the rules that were relevant to the project. This is why you have like a drop at the middle. And also, we'll go through all the branches and the pull requests that you're doing and give you some feedback on it. Also, you can use CodeBit to do code quality or code review. This one actually is giving you quick wins that I haven't found on Codacy. We're also using Code Factor. It's quite the same, actually. They all work on the same basic with hotspots and regarding on your branches and PR. For security and also for code quality, we're using LGTM. So they said that they find and prevent 0 days, which is kind of amazing. Yeah, so it's the same. They'll go through the branches and the PR and give you deltas and a heat map on where you have issues. This one is cool this is specifically for React. So you can see there's like a potentially inconsistent state updates, which is good for developers because sometimes those tools will just throw an error and you don't have any context or documentation around it. So if you click on that, they'll give you actually some sort of recommendation and snippets and also reference to the official React documentation. You can also compare your project to other open source projects or a project using LGTM. We're also using guardrails for security. This one is good because it's actually scanning the code and let you know if there's any hard-coded secrets, which is usually when developers push API or tokens secrets in GitHub, which is pretty bad. They also scan insecure use of SQL queries or vulnerable libraries. I don't have any cases here. Everything is green, which is fine, but I haven't any case to show you here. For the dependency management, we're using Sonatype Depth Shield. This one is quite intense, actually. It's only raising issues, and it's based on CVSS. So for those of you who are curious on how CVSS, this 7.4 score is calculated, this is actually the metrics that they're using with the attack vector, the scope, confidentiality, integrity, availability, all of those. And this is how we get the score. So this is pretty intense, actually. If you want something simpler, I would recommend Dependabots. So this tool actually raises automatic PR, and they will tell you how to actually bump your dependencies. Also, they will give you a compatibility score, which means it will compare with other companies. If it goes through their CI/CD without any issues, it will bump the score. And this is the integration through Slack. Maybe you're more familiar with Snyk as dependency management. So usually what Snyk does, it scans the package JSON or the yarn lock and let you know which package is vulnerable. They will also give you a little bit of explanation, documentation on it. And this is the integration through Slack. If you're wondering how to integrate through Slack, all of those tools are using webhooks. It's pretty straightforward. Usually, when you go to the dashboard of the tool, you have an integration tab, and you can just pick and choose what integration you want to do. But for Slack, it's based on webhooks. Also, Snyk will send you emails if you have any new vulnerability. And for monitoring, we're using Rollbar, which is real-time full-stack exception reporting and debugging for the developers. You have to push your website live, actually, to have this tool triggered. And they will give you browser OS, all kind of cool information on the monitoring side. So this is an example of when you raise a PR, you actually have the tools fully integrated within GitHub. We're also using PR size. So if you go here, like you have the size/m to just give you an idea of how big is your PR. And this is what you have when all the check has passed. But usually you don't have this at the first run. It's more like this, like 1 or 2 tools are actually failing. And it's actually more like this, because you need to actually have one approving review. from one of those. And you can also make some of the tools record. This is when you protect your branch. You can actually choose which tools you want to have record. So this is when all your tools, the check are passing, everything's happy, everyone's happy, the team is also partying on it. This is another example through the integration on Slack. So you don't have to go through the dashboard. You actually have with the color code, you can see like the orange and yellow and the red one. They will let you know which app are passing and which one are failing. So you can just go on Slack and see everything on one place. We're using Netlify for deployments, and the same, there's a Slack integration on it. So once you have integrated your tools, you actually have all of those badges provided by every tools. So you have Netlify, Circle CI, you have code review, code quality, will RGTM, code coverage, and Snyk for the last one. This is on your, you can put this on your README. So when you have an open source product, it's always good to have those, like if you want to have more contributors, they can actually see the health of your project. Just a quick one on the project management side. We actually try to use GitHub at most. So we've created a series of labels and milestones. If you're familiar with Jira, it's basically epics here. And you can actually gather tickets through one epic or milestone, as you're saying. And they also provide Kanban. This one is actually automated, so you don't have to touch anything. The tickets will just go through the board. If you're actually reviewing the PR, if you close the PR, it will just move by itself. So this is great, actually, but as you've seen, there's like a lot of tools, and there's like different dashboards to go to. So we're actually thinking moving to GitLab, because everything is built in to GitLab. And also for the open source, their plan is actually free. The gold or platinum, I can't remember which one, but with all those goodies is actually free for open source. I also wanted to introduce you more tools, security tools to do online scan. Are you familiar with webhint? It was called SolarWhale before that. So basically, what you would do is just put the URL of your application, your website, and it will go through different scans. So you would see accessibility, performance, security, and give you a recommendation around those. You might be more familiar with Google Lighthouse, that you can find actually within your DevTools on the audit tab, and you can just perform an audit, and it will give you also recommendation around those areas. Lastly, security headers has been created by Scott Helm, who's also a security researcher. So you can just scan your site. I've done it with Facebook, and you'll have a grade at the end and give you an overview of security headers. So what's next for you? If you've been interested by what I've said around OWASP and security, you could become a security champion. So basically, a security champion will be the bridge between developers and the security team, because usually the security team is a small team, and they can't go to all of the Scrum ceremonies, for example. So having a security champion within each feature team, for example, would give more visibility, and you can have also feedback from developers. Also, the second phase would be to actually implement security champions to designer, project manager, product owner, and different people within the company. If you're interested to know how to move to cybersecurity, I've actually wrote a piece on Medium where I gather a lot of resources. If also you're interested in joining, there's the OWASP London chapter, and also if you're a woman or identify as a woman, you have the Ladies of London Hacking Society this week. They're hosting a meetup. And yeah, I'll finish by get secure, be secure, and stay secure. Thank you.
Any questions?
Hi, thanks for that. That was really interesting. Of the code quality tools that you mentioned, things like Codacy, along those lines, I guess I was surprised to see that there were a few that I thought did a similar function. So I didn't know what your thoughts were on kind of having several tools that may have overlap.
Yeah, so basically, because as I said, for open source, they're all free. So we're actually trying different tools and see which one is the most relevant for our projects. So I'm waiting to have enough metrics to actually pick and choose which one is the good one. Because the first one we've picked was Codacy. And it was a little bit flaky at the end. So that's why we tried to implement a code factor and code bit. So yeah, we might probably need a couple of more months to actually have proper metrics and get rid of some of the tools.
Yeah, and in terms of how you've done the testing, would you recommend kind of testing several at once if I were to kind of take one?
Yeah, probably, because you might have like different metrics actually. As I said, for CodeBit, you have like quick wins. So you might have like those small wins to that might actually bring more value to your project. Yeah.
Cool. Okay, thank you.
Any more questions at all? No? Okay. Well, thank you, ladies and gentlemen.
Thank you.
For being here. Thank you to our speakers, Tom, Luke, and Sonia. So round of applause, please. And with that, we have come to the end of our React London today. Just to let you guys know, Red Badger, we're recruiting. So you can hit us up, jobs@red-badger.com. Also, if you want to be a speaker, potentially one of you, if you know somebody wants to be a speaker, drop us a message at hello@react.london. Thank you, Facebook, for having us. Thank you guys for turning up. And there's still more beers there. And if anybody wants to finish networking, talking, we're heading over to the Marquis of Granby pub up the road. So you're welcome. If not, travel safely home. And yeah, enjoy your evenings.